Stan Gibilisco here. I'd like to show you how to put together some very simple electronic components to simulate the operation of a digital logical OR gate. All you need is two rectifier diodes, just plain typical rectifier diodes rated at a few hundred volts IV and about an amp or so, a 470 ohm 1/2 watt resistor, and a lantern battery that supplies 6 volts. The way that it works, basically remember that an OR gate, the output is low, if and only if both inputs are low. If either or both input is high, the output is high. So you can build this little thing on a circuit board and test it using your lantern battery. When you have a gate or input in the low state, you should short it out to ground. When you want it to be in the high state, you should connect it to the positive terminal of your lantern battery. So if both inputs are low, that means 0 volts here and 0 volts here. Essentially, no current is going to flow in this circuit whatsoever. It's just going to be dead grounded all the way through, and your output is going to have 0 volts on it. So that verifies that condition. If input X is high, but input X is low, then what happens, the positive voltage here allows electrons to flow through the diode against the arrow like that, creating in effect an outflow of electrons here, a positive 6 volts here, and a high at output Z. The same thing happens, just mirror image upside down, if Y is high and X is low. And of course, if both inputs are high, then electrons can flow through both diodes to the positive terminal of your lantern battery, creating an outflow here of electrons and a net positive volts, 6 volts high here. So that in effect is a very simple components you can assemble to show how a logical OR gate works. And remember, this is the inclusive OR function, meaning that if both inputs are low, the output is low. In the exclusive OR situation, the output would be high if both inputs are low, but you rarely see that in digital logic applications in conventional purposes. Stan Gibilisco, signing off for now. Until next time, so long.